Alright, welcome to the first differential equations video. In class we reviewed integrals and derivatives, the two major topics from calculus. We may have even solved a differential equation or two, but in this video I want to talk about what it is to be a differential equation and maybe do a little bit of vocabulary, maybe talk a little bit about how differential equations can be used, where they pop up in the world. Let's start by looking at an old algebra equation. In algebra, you may have an equation that looks something like that. If you're given this equation in algebra, the goal is pretty clear. The goal is to solve for the unknown, or in this case, x. Now let's look at a differential equation. A differential equation is just an equation that has a derivative in it. So there's an example that I just made up of a differential equation. There's a derivative right here, y prime, and it's got an xy on the other side. Now it's always good to keep in mind what this prime means, and I'll write it down explicitly in this case. The prime is the derivative of y with respect to the variable x. Now with our algebraic equation we only had one variable, so we could just solve for that variable. In our differential equation we're always going to have at least two variables, and it's important to know what the independent variable is and what the dependent variable is. If you have the differential equation written out in this form, it's actually really easy to tell. The independent variable is always going to be the variable in the, the bottom part of the derivative. That's x. The dependent variable is always going to be in the top part of the derivative. That would be the y. The reason I write this out is because the goal of solving any differential equation is to solve for the dependent variable in terms of the independent variable. So our goal is to solve for y in terms of x. I'll write that down. So the goal in any differential equations problem is to solve for the dependent variable, in this case y, in terms of the independent variable, in this case that's x. Now I did put a little s in parentheses here. There could be more than one independent variable. That's really a problem for a future course, not this Intro to Differential Equations course. But we'll talk a little bit about that later. Just as a sort of a side note, in algebra you often have equations that have two variables in them as well. And it's not always clear, unless you're given instructions, what you're supposed to do with this. Are you supposed to solve for y maybe, get y by itself? Are you supposed to get x by itself? Maybe we're supposed to graph this thing in two dimensions. It's not always clear what you're supposed to do here. But in differential equations, I can't really off the top of my head think of a time if you actually have a differential equation, the goal is always to solve for y in terms of x, or for the dependent variable in terms of the independent variable. Sometimes that's not even possible, but the goal is always to learn more about this function right here. Okay, I'm going to erase that, and I'm going to say one more thing. Often in algebra we had equations that had things like this. We have more than one unknown in this thing, and we can rearrange it in different ways. I suppose the equivalent situation in differential equations would be if we had, say, some extra parameters there in our differential equation. Unless these are defined as functions, then these a and b's, we just call them parameters. And they're constant with respect to x and y. They don't depend on x and y. So you would just solve the differential equation with these parameters, just left in there, treating them as if they were constants. Okay, let's move on and talk a little bit more about differential equations, a little bit more vocabulary. If I may move down a bit here, we have this big group of differential equations. Differential equations can actually be split up into two main pieces, ordinary and partial differential equations. We call those ODEs and PDEs. Oops. This class is going to cover 100% ordinary differential equations. So Math 261, this class that you're in right now, that's going to be all ordinary differential equations. In the future, you may choose to take a partial differential equations class. I'll just give you a 30-second rundown of what this means. A partial derivative, I believe you hopefully remember, looks something like that. The only reason you would ever use a partial derivative is if you have more than one independent variable. So this right here would be a partial differential equation. You have a derivative with respect to x, derivative with respect to y, and these are actually second order derivatives. And the goal would be to find the dependent variable in terms of the independent variable. So you're looking for a function of x and y in this example. So since we're dealing with only ordinary differential equations in this class, what that means is we're really only going to have one independent variable in each one of these problems. So that's just kind of an FYI. Moving on, I'm going to erase this so it looks a little better. Ordinary differential equations can be split up into two pieces. The two main pieces would be linear and nonlinear. We're going to talk about what this means, linear versus nonlinear, in class. I think the in-class interaction will be helpful in understanding that. But there is one little piece of vocabulary I want to tell you about in this video because it's really simple. Order. The order of a differential equation is the highest derivative in the differential equation. So that might not be the best definition, but if we go back up to the very beginning, we had a differential equation up here. What's the order? Well, we only have one derivative, a first derivative in this problem, so it's a first order differential equation. If we came back down here, I could write down an example of a second order differential equation. Something like that. There are two derivatives in this differential equation, so it is a second order differential equation. It just so happens that this is also a linear differential equation. So this is a second order linear differential equation. Again, we're going to talk in class about what it means to be linear versus nonlinear. But giving the order for now, at least, giving the order and whether it's linear or nonlinear for a differential equation, combine those two, that's called classifying the differential equation. And it's important to be able to classify a differential equation because the order and whether it's linear or nonlinear tells us how we're supposed to go about solving the differential equation. So, okay, that's probably enough for your first video. Thanks for listening. I promised a quiz with every one of these videos. We haven't done a ton of quizzable material, but here's the best I can do. State the goal when solving the differential equation. Basically, what are you trying to find as your last step when solving this differential equation? You don't have to solve it, obviously, but what is your goal? Also, give the order of this differential equation here, and this sort of a trickier one, state the goal when solving this differential equation right here. That's a partial differential equation. Again, you don't have to solve it, just tell me what you're trying to do if you are solving it. All right, bring this quiz in and turn it in at the beginning of class next time, and I'll see you there.